All right, everybody. Today is the start of Chapter 10, Sequences and Series. So today we're going to do 10.1, Sequence and Summation Notation. So we're going to do a little bit, switch gears a little bit. This is 10.1. This is going to be, I'm going to break it up into 2 days. That's going to be day 1. So first we're going to start, a sequence is a list of numbers like the Fibonacci sequence. The Fibonacci sequence is just a famous sequence of numbers, and the numbers are formed by adding the two previous terms. So you get 2 by doing 1 plus 1, you get 3 by doing 2 plus 1, you get 5 by doing 3 plus 2, you get 8 by doing 5 plus 3, and you get 13 by doing 8 plus 5. So the next term would be 13 plus 8, and so on and so forth. So I'm just going to go over a little notes down here. So it says a sequence is a function. You can have a sequence that is infinite, which means it goes on forever, or a finite sequence, which means it does not go on forever. So the domain of your sequence. The domain is basically like what term number it is in the sequence. So here's the Fibonacci sequence down here. 1, 1, 2, 3, 5, 8, 13. So basically this is the first term. This is the first term. This is the second. This is the third. This is the fourth. And then these are the actual values. So this would really be like a sub 1, which is the first term. This is a sub 2, which is the second term. This is a sub 3, like a subscript. The subscripts are the domain. Subscript is domain. So like this 8 is the 6th term in the sequence. 6th term in sequence. They're like functions. So like for the 6th term in the sequence, f of 6 is 8. The 6th term is 8. The third term in the sequence, so f of 3, the third term in the sequence is a3, so that would be 2. So it's like x and y, domain and range. Our sequence notation, use these curly brackets, a sub n. So again, just don't be confused by the first term is like a sub 1, the second term is a sub 2. The nth term is a sub n, and then that's the domain, and then the range is whatever the value is. So again, we use the letter a with a subscript. It's used to represent function values of a sequence rather than the usual function notation. So the subscripts make up the domain. Okay, so we're gonna try one. So it says right here, we're gonna write the first 4 terms of the sequence whose nth term is given. So a sub n equals 3n plus 4. So to find the first term, or a sub 1, now see how I have a sub 1, I put this little 1 here. For n, I'm going to do the same thing and put a 1 in for this n. So it's going to be 3 times 1 plus 4, which is 7. So that makes 7 a1. The second term, so that would be a sub 2. So again, I put a 2 in for here where this n is. 3 times 2 plus 4, which is 10. So that's a 2. So it says you're going to do it for the first 4. So the third term, which is a sub 3, would be 3 times 3 plus 4, which is 13. And the fourth, which is a sub 4, would be 3 times 4 plus 4, which is 16. So those are all the first 4 terms. So you have 7, 10, 13, 16. Same thing for this one. You're just plugging in. This one's just a little more complex. So a1 is going to be negative 1 to the first over 3 to the first minus 1, which is negative 1 over 2, which is negative 1/2. And now you're going to do it again. So I'm just going to go down here, a sub 2, negative 1 to the second over 3 to the second minus 1, which is negative 1 over, what is that, 8, right? Yeah, Oh, I'm sorry, that is positive 1 because it's negative 1 squared. So it's 1 over 8, so it's 1/8. And you do the next one. A sub 3, negative 1 to the third over 3 to the third minus 1. So that's negative 1. Negative 1 over 3 to the third is 27 minus 1 is 26. So it's negative 1 over 26. And then if you were to do A4, you should get 1 over 80. So your sequence is negative 1/2, 1/8, negative 126, 1 over 80. And that's example 1 and 2. All right, example 3, it says use the recursion formula to find the first 4 terms. So recursion formula, what does that mean? So I'm just going to define it right here. Recursion defines the nth term, so like the next term, or whatever term you want, nth term of a sequence So it defines the nth term of a sequence by the previous term. So what it basically means is you use the previous term. The big thing you need to remember is you're going to use the previous term. Right here, you're going to see this a little bit, n minus 1. That means the term before. So if you think about it, if you want A3, the third term, that's the one you want. That's just a little example. If you want A3, you're going to use A2, which is A3 minus 1, which is A2. Term before. So you use the previous term. So in this example, they give you A1, and you want to find the first 4 terms. So it says A sub n equals 3 a n minus 1 minus n sub n minus 1 minus 1. So we're going to use the first term. So if we want A2, 2 is n. We're going to use 3 times a, n minus 1, so 2 minus 1 minus 1, which is 3 times a1 minus 1. Oh, I have a1. So a2 is 3 times 5 minus 1, which is 14. So how would you find a sub 3? Oh, you would use now 3 times 14 minus 1. 3 times 14 is what? 42 minus 1, 41. Then to get a4, you do 3 times 41 minus 1, which is what? 124 minus 1. You get what? 123. So now you have the first, 4 terms. Let me make sure my math is right on that one. 3 times 41 minus 1. Oops, sorry, 122. Yep. 122. And that is how you get it. So recursion, when you use recursion, you're always going to use the previous term. You're going to use the previous term. All right, the last thing this video is going to talk about is factorial notation. So factorial notation is basically when you see something factorial, it's the product of all the numbers being multiplied together below it. So like here, 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So if I were to write like 5 factorial, it would be 5 times 4 times 3 times 2 times 1. So if you had like 100 factorial, 100 times 99 times 98, all the way down. And then you have 0 factorial, which is 1. So we're just going to use that concept to find the first 4 terms of the sequence. So factorial, it's not, it looks like an exclamation point, but it's the factorial. So let's do a sub 1. So a sub 1 is 2 to the first over 1 minus 1 factorial, which is 2. 2 to the first is 2. 1 minus 1 is 0 factorial. Now from up here, it says 0 factorial is 1. So we have 2 over 1. So the first term is 2. First term in our sequence is 2. So next, we're going to do the second term. So that's a sub 2. So now I'm going to do 2 not to the first, but to the second, over 2 minus 1 factorial. So if you look, I keep changing where the n is. So 2 squared is 4. 2 minus 1 is 1 factorial. 1 factorial is 1. Second term is 4. Now we'll do the third. 2 to the third over 3 minus 1 factorial. 2 to the third is 8. Now we have 3 minus 1, which is, now it's in parentheses, so I can do 3 minus 1, which is 2 factorial. So 2 factorial is 2 times 1, which is 2. So I have 8 over 2 times 1, which is 8 over 2, which is 4 again. And now A4, 2 to the fourth over 4 minus 1 factorial. 2 to the fourth is 16 over 3 factorial. So 16 over 3 times 2 times 1, which is 16 over 6, which is 8 over 3. So your first 4 terms are 2, 4, 4, 8 over 3. Those are your first 4 terms. So using factorial, same thing. You just have to do the 3 times 2 times 1, or 4 times 3 times 2 times 1. So now, obviously, your next question is, what happens when the factorials are huge? Am I going to make you sit there and go 18 times 17 times 16 times 15? You might be thinking yes, but the answer is no. So when you evaluate factorials, I'm going to show you how to do it. So remember, 18 factorial is 18 times 17 times 16. So we're going to just start writing it. 18 times 17. Now what's left? 16 times 15 times 14, which is really 16 factorial. Oh my God, look at the bottom. What can I do? Now let's take this for a second. 18 factorial is 18 times 17 times 16 times 15, 14, 13, 12, 11, all the way down. If I stop here, that's what's left. 16 times 15 times 14. I can just whoop, whoop. And now I'm left with 18 times 17, which is, since I am going to use my brain here, I am going to take a guess, and it is 306. Let's check my work, 306. I'm just kidding, I had that written down before. All right. Next one here, 20 factorial. Let's start breaking it down. 20 times 19 times 18. We're going to stop at 18 because the denominator is 18. 2 factorial, I'm just going to do 2 times 1. That's nice and short. Then I also have to times that by 18 factorial. So I can cross these out, and I'm left with 20 times 19 over 2 times 1. And I can just use my calculator. It ends up being 190. Let's see, 20 times 19 divided by 2, 190. Very good. Last two, just to show you the difference here, what the parentheses mean. This is 2 times 3 factorial, so I'll just do it in a different color just to show you the difference. This is 2 times 3 times 2 times 1, which is 2 times 6. So this one's going to be 12. The difference here is you have to do the 2 times 3 first because it's in parentheses to give you 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Type that on your calculator, 720. Those are your notes for today. I'm just going to do the MyLab, and that's going to be it. Have a great, for A day, have a great, oh no, this is next week, so have a good rest of the week, I guess. All right.